Hi, this is a quick video walkthrough of a lab I did the other day for my old student Heather, who attached tiny little scallops to Velcro because I told her to, so I probably owe her this. Anyway, this lab is about transpiration through leaves, and we measured it through a number of leaves and then kind of multiplied that up to find out how much water was being transpired by all the trees on our campus. But obviously this could be done in a lot of different ways. There's actually a kit from Ward or Carolina that addresses this, but it involves plastic tubing and petroleum jelly and tiny little clamps and pipettes, and you're measuring the volume of water that is being drawn through this pipette. It's really kind of complicated for this purpose. So I have just a simple dirty version that I do. And it involves a small test tube and a piece of parafilm. We're going to put the parafilm over the top of the test tube. Okay, the test tube has water in it. This is aged water, I think, because I don't want to freak the leaves out osmotically. And basically I'm going to poke a little hole in the top of the parafilm. I'm going to go outside and get myself a leaf. And just like you would if you had some flowers, before you put them in the vase, you're going to cut the end off of the stem. This is not a stem, this is the petiole, but we're going to cut the end off that and put it through the little hole so that there it is in the test tube. Now this is a closed system, presumably because of the parafilm. The only way for that water to leave the test tube is to go through the leaf to be released from the stomata on the backside of that leaf. So if we weigh this just as it is, so what I do is I take an Erlenmeyer and I put it on my scale, and I tear the scale so that weighs 0, and I just put this in the flask, get a weight from the system, that's the tube and the leaf, and then I'm going to put this out in the sun, usually on some pole, and leave it out there for a certain amount of time. Then I'm going to bring it back into the lab, and I'm going to weigh it again. And the water, the weight that was lost from the system is only water, and it's only water that left the test tube by traveling through the leaf. So we're going to take a weight of water that was lost, and we can change that into a volume because 1 milliliter of water, 1 gram. Okay. So the only part after that is really doing the multiplying up, and my students make an estimate of the number of leaves in the tree. I usually leave that up to them to figure out how to do it. This is an ecology class and they have to make some assumptions. But what they usually do is they count the number of leaves on one branch, a representative branch, and then they multiply that by all the branches they can see in the tree. So we get leaves per tree. I think we were somewhere like 2,000, 3,000 like that when we did this the other day. Then we do a count of trees in an area, in a plot. It could be per acre forest. It could be the number of trees on campus, which is what we did, and I think we have about 300 trees on campus. And then we estimate how many hours per day there is sunlight, because this transpiration only happens when photosynthesis is occurring. So the number of hours of sunlight is going to control how long this goes on per day. Weight loss per leaf times leaves per tree times trees per plot times hours per day is going to give us weight loss of water per day for the entire plot, for the entire campus. And because we know that a milliliter of water weighs a gram, we can do all the unit unit conversions, which are so much fun in science class, and it's not that complicated. It's not that time consuming. When you put these leaves outside, then you've got some time waiting for them to transpire to count the leaves in the trees and count the trees on the campus. So it kind of works out nicely. I think we did it in about we did it in about 2.5 hours, the whole thing that we did the other day. I hope this was useful. If you have any more questions, send me a message. Thanks.